was fighting an industrial war against an enemy with overwhelming material superiority, and no amount of tactical skill could overcome that disparity. The proximity fuse was just one example among many. American production statistics were available through intelligence channels. The United States produced over 300,000 aircraft during the war. Germany produced about 94,000. American ship production exceeded that of all other nations combined. American munitions production was so vast that allies like Britain and the Soviet Union were supplied with American equipment, even while US forces fought on multiple fronts. The arithmetic was brutal and inescapable. Germany was outnumbered, outproduced, and increasingly outperformed technologically. The sophisticated weapons Germany did produce, like the Me-262 jet or the Type 21 submarine, came too late and in too few numbers to matter. Meanwhile, America was producing millions of trucks, billions of rounds of ammunition, and yes, 22 million proximity fuses. The scale of production was so vast that waste became acceptable. American forces could afford to expend ammunition at rates that would bankrupt the German war economy. Becker had seen this disparity crystallized in those 3 captured shells on his examination table. Each one represented a triumph of miniaturization, precision manufacturing, and mass production. Each one proved that America had achieved an industrial sophistication Germany couldn't match. And there were millions more where those came from. The VT proximity fuse stands as one of World War II's most significant yet least known technological achievements. It saved thousands of Allied lives, first by defending ships from air attack, then by devastating German ground forces at critical moments. But from the German perspective, it was something else. A revelation of just how outmatched they were. Not outmatched by a small margin that skill could overcome, but fundamentally, mathematically outmatched by an industrial system operating at a scale they couldn't approach. Heinrich Becker was one of many German professionals who saw this truth and tried to communicate it. Like the others, he was ignored. The Nazi regime's commitment to racial and technological superiority mythology made it impossible to accept reality when reality contradicted ideology. The cost of that blindness was catastrophic. The war continued for 4 more months after Becker submitted his report. Hundreds of thousands more died, millions more were displaced, and German cities were reduced to rubble. All in service of a cause that multiple competent professionals had already concluded was mathematically impossible. The lesson extends beyond World War II. When ideology became January 1945, a frozen warehouse on the outskirts of Berlin. Dr. Heinrich Becker, chief engineer at the Heeresversuchsanstalt Kummersdorf, Germany's primary weapons testing facility, stared at the objects laid out on the examination table before him. 3 American artillery shells, 105 millimeters, recovered from the Ardennes battlefield. They looked ordinary enough from the outside. Standard high-explosive rounds, the kind that had been raining down on German positions for months. But these shells were different. They had been found unexploded, buried in the snow near the town of Bastogne, and the reports accompanying them were disturbing. Frontline soldiers described a new American weapon, artillery shells that detonated in midair with perfect precision, raining shrapnel down from above. Shells that made foxholes and trenches useless. Shells that seemed to know exactly when to explode. The reports seemed impossible. Airburst artillery required precise timing fuses, calculated by experienced gun crews based on distance, altitude, weather conditions. Getting it right was difficult. Getting it right consistently was nearly impossible. And getting it right in the middle of a blizzard, with poor visibility and chaotic battlefield conditions, was beyond the capabilities of any army. Yet the Americans were apparently doing exactly that, every single time. Becker had been summoned to find out how. As he carefully began to disassemble the first shell, removing the nose cone to expose the fuse mechanism, Becker had no idea that what he was about to discover would be more than just an explanation for a tactical problem. It would be a revelation about the true nature of the war Germany was losing. A war not of soldiers and tactics, but of scientific capability and industrial capacity on a scale that defied comprehension. Becker worked methodically, photographing each step of the disassembly. His hands were steady, despite the knowledge that even a dud artillery shell could be dangerous. One wrong move, one accidental trigger, and he'd be scattered across the warehouse. When he finally removed the outer casing of the fuse assembly, he stopped. For a long moment, he simply stared. Inside the nose of the shell was a device unlike anything he'd ever seen. a compact assembly of components, precisely machined and carefully arranged. At first glance, it looked like a miniature radio set, which was impossible. Radios were delicate instruments. They required careful handling. The idea of putting one inside an artillery shell that would experience forces of 20,000 times gravity when fired was absurd. Becker called over his assistant, Hauptmann Franz Weber, an electrical engineer who'd worked for Telefunken before the war. "Franz, come look at this. Tell me what you see." Weber leaned over the table, his eyes widening. That's a radio transmitter, and a receiver, and what looks like an amplifier circuit." He paused, his voice becoming uncertain. "Herr Doctor, this can't be right. These components shouldn't survive being fired from a gun." Becker nodded slowly. "But they did. This shell was fired. The rifling marks on the casing prove it traveled through a barrel. Somehow, impossibly, this radio equipment survived the launch and remained functional." Over the next several hours, Becker and his team carefully documented every component. There was a miniature vacuum tube, smaller than anything in German production, a battery system with a clever activation mechanism, an antenna that deployed after firing, a trigger circuit connected to the main explosive charge. As they mapped out the system, the function became clear. This was a proximity fuse. The transmitter sent out radio waves. When the shell approached the ground, the reflected waves would trigger detonation at the optimal altitude for an airburst. No calculations needed, no timing required. The shell itself decided when to explode. The elegance of the design was stunning. But as an engineer, Becker immediately understood the implications, and they were terrifying. Becker sat at his desk, staring at the component analysis. Every part of the American fuse represented a significant engineering achievement. Taken together, they represented something beyond Germany's current capabilities. The vacuum tubes were the first problem. In 1945, German vacuum tubes were relatively large, fragile devices. They required careful handling and couldn't withstand significant shock. The Americans had somehow miniaturized them and ruggedized them to survive artillery launch. That alone suggested a level of manufacturing sophistication that was troubling. But it got worse. The battery system was brilliant. It used a glass vial filled with electrolyte. The force of firing the shell would shatter the vial, allowing the liquid to mix with the battery components and activate the power source. This meant the battery could be stored indefinitely without degradation, only becoming active when needed. German engineers had theorized about such a system, but implementing it required precision glasswork, carefully formulated electrolytes, and quality control standards that German factories, increasingly bombed and operating with forced labor, could no longer maintain. Becker called a meeting with his senior staff. Around the table sat some of Germany's most experienced weapons engineers. He laid out his findings. "Gentlemen, we are looking at a functional miniature radar set designed to survive being fired from an artillery piece. The Americans have solved problems we've been struggling with for years. The question before us is simple. Can we replicate this?" The discussion that followed was sobering. Every engineer present could see the brilliance of the design. Every engineer also understood that Germany couldn't build it. Dr. Wilhelm Schaefer, who specialized in electronics, shook his head. "The miniaturization alone is beyond us. Our vacuum tubes are too large, too fragile. To create tubes this small while maintaining functionality and durability would require manufacturing capabilities we don't have." Another engineer pointed to the materials analysis. "The casings are made of high-grade aluminum alloys. The circuitry uses copper that shows no signs of shortages or substitution. Every component is built to specifications we can no longer meet." Becomes more important than evidence, when loyalty is valued over accuracy, when uncomfortable truths are suppressed rather than addressed, catastrophic failure becomes inevitable. Becker's examination of those 3 artillery shells should have triggered a fundamental reassessment of Germany's strategic position. Instead, it was filed away and forgotten. The smart weapons kept falling from the sky. The arithmetic of defeat continued its inexorable calculation. And the Third Reich marched toward its inevitable end, blind to a reality it refused to see. The proximity fuse changed warfare forever, but its examination by German engineers revealed something even more important: the fatal consequences of valuing ideology over truth, of choosing comforting myths over uncomfortable mathematics. In the end, reality doesn't care what you believe. The smart shells proved that beyond any doubt. Becker made notes. Then he asked the question that haunted him. How many of these do you think the Americans have produced? The room fell silent. Finally, Hauptmann Weber spoke. Based on the reports from the Ardennes, thousands, possibly tens of thousands. They're using them as standard ammunition across entire artillery batteries. Becker did a quick calculation. Each fuse required dozens of precision components: vacuum tubes, resistors, capacitors, batteries, antenna assemblies. All manufactured to exacting standards, all assembled into a device small enough to fit in an artillery shell. And the Americans were producing them in massive quantities. "Gentlemen," Becker said quietly, "we need to understand what this means. The Americans haven't just developed a new weapon, they've developed a production system capable of mass-producing complex electronics under wartime conditions. While we're struggling to make basic ammunition, they're turning out miniature radar sets by the thousands." One of the older engineers, a man who'd worked in German industry since before World War I, spoke up. "Herr Doctor, with respect, I think you're underestimating the scale. If they can mass-produce something this complex, their industrial capacity exceeds anything we've imagined." Becker knew the engineer was right, and that realization led him to request something unusual: access to broader intelligence data on American production. 3 days later, Becker sat in a secure conference room with intelligence reports spread before him. What he read confirmed his worst fears and exceeded them. The American fuse program, codenamed VT for variable time, had been massive. Intelligence suggested it was one of the largest wartime projects, rivaling even the atomic bomb program in funding. Fuses were being manufactured at multiple facilities. Western Electric, a telephone company, had converted production lines to make them. So had other electronics manufacturers. The Americans had taken their peacetime industrial base, their experience with mass production of consumer electronics, and weaponized it. Becker pulled out German production figures for comparison. In 1944, Germany had produced approximately 40,000 aircraft total. The Americans were producing more proximity fuses than that every single day, and they were just artillery fuses, a small part of America's overall war production. The intelligence reports contained other troubling data. The Americans had first used these fuses in anti-aircraft roles in 1943. They'd achieved remarkable success rates against Japanese aircraft and German V-1 flying bombs. The fuses had been kept secret from ground combat, specifically to prevent Germany from capturing and reverse engineering them. The fact that they'd been deployed at the Battle of the Bulge meant one of two things. Either the Americans were so desperate they'd risk the secret, or they were so confident in their industrial advantage that compromise no longer mattered. Becker suspected it was the latter, and that suspicion was confirmed by another document, a British intelligence assessment of American industrial capacity. The United States was producing more war materiel than all other nations combined. Not just more than Germany. More than Germany, Britain, the Soviet Union, Japan, and Italy combined. The scale was incomprehensible. One statistic stood out. In 1944, American industry produced over 96,000 aircraft. Germany, with all its vaunted engineering expertise, produced about 40,000. The ratio was more than 2 to 1, but American aircraft were, on average, larger and more complex. A B-17 bomber required more aluminum and man-hours than 3 Bf-109 fighters. The material disparity was so vast, it rendered tactical and operational skill almost irrelevant. Germany could win every battle and still lose the war through simple attrition. Becker realized he was looking at the mathematical proof of Germany's defeat. The proximity fuse wasn't just a weapon. It was evidence of an industrial system operating at a level Germany couldn't approach, let alone match. Becker spent a week compiling his findings into a comprehensive report. He knew it would be unwelcome. The Nazi regime didn't respond well to pessimistic assessments, but as a scientist, he felt obligated to present the truth as clearly as possible. His report was divided into sections: the technical analysis of the fuse itself, complete with detailed diagrams and component breakdowns; an assessment of Germany's ability to replicate the technology, which he concluded was impossible with current resources; and finally, a strategic assessment of what the fuse's existence revealed about American industrial capacity. The final section was the most damning. Becker wrote, "The VT proximity fuse represents not merely a tactical advantage, but a fundamental strategic disparity. The ability to mass-produce complex electronic devices in wartime suggests an industrial base of unprecedented scale and sophistication. If American industry can manufacture 40,000 miniature radar sets daily, while simultaneously producing aircraft, tanks, ships, and conventional ammunition in overwhelming quantities, then Germany's material position is not merely unfavorable, but mathematically hopeless. No amount of tactical skill or soldier bravery can overcome a production ratio of this magnitude. He concluded with a stark recommendation. Germany should seek immediate armistice before additional casualties are incurred in a war that can no longer be won. Becker's commanding officer read the report with a grim expression. Heinrich, you know this will be seen as defeatist, possibly treasonous. Should I alter my findings? Becker asked, knowing the answer. No. The report is accurate. I'll forward it through channels. But prepare yourself. The leadership doesn't like uncomfortable truths. The report was sent to the Oberkommando der Wehrmacht, the German High Command. Becker never received an official response, but through informal channels, he heard it had been dismissed as excessively pessimistic and defeatist in nature. One general had reportedly said, "This engineer has been demoralized by enemy propaganda." The American fuse is a trick, a piece of luck, not evidence of systematic superiority. Becker wasn't surprised. He'd seen this pattern before. Intelligence that contradicted Nazi ideology was rejected regardless of evidence. The regime had built itself on the premise of German technological and racial superiority. Admitting that America had surpassed Germany in industrial and scientific capability would undermine the entire ideological foundation. But Becker knew the truth. He'd held the evidence in his hands. He'd done the calculations. Germany wasn't losing because of inferior soldiers or flawed tactics. Germany was losing because it was fighting an industrial war against an enemy with overwhelming material advantage. And no amount of willpower or ideological fervor could change mathematics. Becker's report may have been dismissed by high command, but it reached some field commanders. One of them, a colonel commanding an artillery regiment, requested a meeting with Becker. The colonel, a veteran of the Eastern and Western fronts, had a haunted look in his eyes. "Herr Doctor, I read your report on the American fuse. I need to know if your conclusions are accurate." Becker nodded. Every word. The colonel was quiet for a moment. "My men faced this weapon at the Bulge. We lost an entire battalion in minutes, not hours. Minutes. The survivors told me shells were exploding above them, that there was no shelter, nowhere to hide. At first I thought they were exaggerating, that the stress of combat had distorted their perceptions." "They weren't exaggerating," Becker said quietly. "No, they weren't." The colonel leaned forward. "Herr Doctor, I've been a soldier for 20 years. I fought in Poland, France, Russia, North Africa, Italy. I've seen every kind of weapon. But this changes everything. How do you fight an enemy who can drop explosions on your head with perfect accuracy, regardless of weather or visibility? How do you train soldiers to survive a weapon that makes every defensive position useless?" Becker didn't have an answer, because there wasn't one. The proximity fuse had fundamentally altered the calculus of ground combat. Traditional infantry tactics, developed over centuries, were suddenly obsolete. The colonel continued, "And if what your report says about American production is true, if they're making these by the tens of thousands per day, then every attack we launch, every defensive position we hold, will be hit by this weapon. We'll be ground down, piece by piece, with no way to counter it." "That's correct," Becker confirmed. The colonel stood, looking out the window at the ruins of Berlin, already battered by conventional bombing. "Then the war is over." "Not officially, not yet. But mathematically, strategically, it's done. We're just waiting for the end." After the colonel left, Becker sat alone in his office. He thought about all the brilliant German engineers and scientists who'd developed remarkable weapons. The V2 rocket, the Me-262 jet fighter, advanced tanks and submarines. Technical marvels, all of them. But they were marvels produced in small numbers, often too late, always in insufficient quantities. Germany had focused on quality and sophistication, while America had mastered quantity and reliability. And in an industrial war, quantity was its own quality. The proximity fuse was just one example, but it was representative of a larger truth. America wasn't just producing more weapons. It was producing better logistics, better training systems, better everything. And doing it all at a scale Germany couldn't comprehend, let alone match. After the war, when production figures were declassified, Becker's estimates proved conservative. He'd actually underestimated American capability. The final production total for VT proximity fuses exceeded 22 million units. 22 million miniature radar sets, each one a sophisticated electronic device, all produced in less than 2 years of full-scale manufacturing. To put that in perspective, Germany's entire production of all types of fuses for all types of munitions during the war was roughly 500 million units. But those were simple mechanical or timed fuses, not complex electronic devices. The Americans had produced 22 million smart fuses, while also producing hundreds of millions of conventional fuses for other munitions. The cost of the VT fuse program was over $1 billion in 1940s dollars, comparable to the Manhattan Project. But unlike the atomic bomb, which was used only twice, the proximity fuse was deployed in massive quantities and had a direct measurable impact on battlefield outcomes. General George Patton, after witnessing the fuse's effects during the Battle of the Bulge, wrote that it won the battle for us. He later stated that he believed it was one of the 3 most important developments of the war, alongside the atomic bomb and radar. The British, who received large quantities of VT fuses through Lend-Lease, conducted their own analysis. Their conclusion: the proximity fuse increased the effectiveness of anti-aircraft artillery by a factor of 5 and ground artillery by a factor of 3. In other words, every shell with a VT fuse was worth 3 to 5 conventional shells. This force multiplication effect, combined with America's already overwhelming production advantage, created a situation where German forces were simply buried under an avalanche of firepower they couldn't counter or match. Becker survived the war and was interrogated by American technical intelligence officers. They were particularly interested in his 1945 report on the VT fuse. "Did you really conclude from examining these fuses that Germany had lost the war?" an American officer asked. Becker nodded. "Not from the fuses alone, but from what they represented. The ability to mass-produce complex electronics during wartime suggested an industrial capacity we couldn't match. Every component, every specification, required resources and manufacturing capability that Germany lacked." "But you were just examining captured ammunition. Surely you couldn't extrapolate the entire strategic situation from that." "I could and did," Becker replied. "When you see a single component of your enemy's supply chain, and that component is more sophisticated than your most advanced weapons, and it's being produced in quantities that exceed your total production of similar items, the strategic conclusion is inescapable." The American officer made notes. "We found your report in German archives. It was marked defeatist assessment, no action required. Did that surprise you?" Becker smiled bitterly. "No. In the Third Reich, accurate assessment of material disadvantage was considered treason. The ideology required belief in German superiority, regardless of evidence. When reality contradicted that belief, reality was dismissed." "So you knew your report would be ignored?" "I knew, but I had to write it anyway. As a scientist, as an engineer, I couldn't remain silent about what I'd discovered, even if no one wanted to hear it." The story of Heinrich Becker and the VT fuse is a microcosm of Germany's larger strategic failure. Time and again, competent professionals presented accurate assessments of Germany's deteriorating position and were ignored or punished. Admiral Canaris warned about American industrial capacity and was dismissed. Albert Speer knew Germany couldn't win a production war, but remained silent. Adolf Galland recognized American aircraft superiority and was called a defeatist. Sepp Dietrich knew the Ardennes offensive would fail for lack of fuel and was ignored. Now Becker joined that list. An engineer who examined captured technology, reached an accurate conclusion about strategic reality, and was dismissed because that reality contradicted Nazi ideology. The pattern was consistent and fatal. The Nazi regime had built itself on myths of racial and technological superiority. When confronted with evidence that those myths were false, the evidence was rejected. It was more important to maintain ideological purity than to acknowledge strategic reality. This willful blindness extended to the proximity fuse's tactical implications. Even after German forces had been decimated by the weapon at the Bulge, even after thousands of soldiers had been killed by airbursts they couldn't defend against, the High Command refused to acknowledge that this represented a fundamental shift in warfare. Some generals insisted it was just a lucky weapon that German soldiers would adapt. Others claimed the reports were exaggerated, that battle stress was causing troops to overstate the fuse's effectiveness. The idea that America had developed and deployed a genuinely revolutionary weapon in massive quantities was too threatening to accept. But the soldiers knew. Every German infantryman who survived an artillery barrage in 1945 learned to fear the American shells that exploded in midair. Foxholes, the basic defensive position that had protected soldiers since World War I, were now death traps. There was no defense, no tactic, no training that could counter the proximity fuse. Becker's report had predicted this. He'd written that the fuse eliminates the primary means by which infantry survive artillery bombardment, creating a battlefield environment where defensive positions offer no protection. He'd been exactly right. What haunted Becker in the years after the war was how obvious the conclusion should have been. The numbers were available. The evidence was clear. Germany